Use calculus to show there is only one stationary point on the curve y is e to the x over x. Determine its exact coordinates and its nature. So this is a quotient, and we can see that u is e to the x and v is x. So du dx is going to be e to the x, and dv dx is going to be 1. So dy dx in this case is going to be v du dx x e to the x minus u dv dx all over v squared. So that's going to be e to the x into x minus 1 over x squared. So dy dx is equal to 0 only when x equals 1. Now let's just explain that. If we look at this expression, to have it equal to 0 means that the numerator has to be 0. E to the x can never be 0. Think about the graph of e to the x. The axis is an asymptote, it never reaches it. So e to the x is never 0, so this can only be 0 when x is 1. Now, if x is equal to 1, y would be equal to e. So we have 1e as our coordinate. We now want the nature. Now that could mean differentiating again. So if we look at this, it's a quotient, and u is x e to the x minus e to the x, and v is x squared. Now note, in here we have a product. U is x, v is e to the x, so du dx is 1, dv dx is e to the x. So v du dx, so that's going to be e to the x plus x e to the x, take away e to the x, so that's just going to be x e to the x. And then dv dx is going to be 2x. So what do we have? We're talking about a quotient. So d2y dx squared is going to be v du dx. So that's this one multiplied by this one. So that's x cubed e to the x. Take away this one multiplied by this one. So that's 2x x e to the x minus e to the x all over x to the power 4. So we've got x cubed e to the x minus 2x squared e to the x plus 2x e to the x over x to the 4. Now we've got a common factor on the top of x e to the x, and that will give me x squared minus 2x plus 2 all over x to the 4, and of course this one will cancel that one down to 3. So we have e to the x, x squared minus 2x plus 2 over x cubed. Now when x is 1, let's look at what happens. So we start with e, and then we've got 1 take away 2 add 2, which is 1 over 1. So it's just equal to e, which is positive. So our second derivative is positive, and that tells us that we have a minimum at 1e.